All right. Hello, everyone. I am so glad that you are here with me today, and I have been waiting for this all week. Hopefully, you received the invite in enough time that you could clear Friday afternoon for 30 minutes to talk about silicone RTV. So, I get a lot of questions, what is an RTV? What is silicone? And I want to address some of those concerns or questions in this presentation. So, hopefully, you guys are going to learn a lot. We're going to have a great time together learning, and let's go ahead and dive right in since we don't have a lot of time. So when we're talking about silicones and sealing diff covers and valve covers, etc., sometimes you might do a repair, and then after you're finished, you're going to get a check engine light, and you're going to wonder, wait a second, I didn't have a check engine light before I did the valve cover. I just had an oil leak. Now I'm showing a P0300 or I'm showing a P0162. And you're like, how could this have happened? Well, one thing that could have happened was you used an acetic silicone that actually emits a toxic fume, acetic acid, and that can damage our O2 sensors, our mass airflow sensors. So this is something that comes up occasionally. You get questions about it. And one of the nice things about silicone, and we're going to dive into the different properties of silicone, is there's a lot of different applications that you can use silicone for, but you have to make sure that you're utilizing it with the right application. We're going to talk about Reinzosil here in a little bit. So when we're talking about silicon and silicone, sometimes there's a little bit of a confusion, right? People think silicon is silicone or silica, and really they're completely different things. They're not even on the same spectrum. Silicon is an element. It's part of the periodic table of elements. And then you have silica, which is sand, quartz. Most of the world's crust is composed of silica, and you can take silica and break it down and make glass, superheat it, and do things like that. But then you have silicone, which is a polymer, right? It has different parts. It has a silicon element to it, and it has oxygen that's also bound to that silicon element. And that's how we get different polymers and ultimately elastomers, in our case, in a sealant, which we call Reinzosil. Now, when we're talking about silicone, the way that silicone can be broken down really makes it so that it's such a versatile product. It doesn't have to be just sealing. It can be for cookware, right? Whether it's that non-stick set of pots and pans that you got for Christmas last year, right? Where you're actually using it so that nothing sticks to it, which is completely opposite of using silicone as an adhesive, right? So that has a lot of different properties, a lot of ways that it can be manufactured. It can be used as a hydrophobic layer to keep water from attaching to a garment. It repel it very easily. And then it can also be used in medical applications, in tubing and insulators. It has a very high heat tolerance. So when you're talking about silicone, it really is a dynamic product that can be used for so many different things. And the structure of silicone is what makes it so easily used and manipulated. It's pretty basic. It's a chain of atoms, and that chain can be manipulated, added new chains, cross-linking, so that we can use it for different functions. Now, when we're talking about RTV, that is a way that the silicone cures, right? You have liquid silicone, you have 1-part RTVs, you have 2-part RTVs, you have a heat cure silicone. In our case, in our use case, we're talking about a 1-part room temperature vulcanizing silicone. And really what that means is the curing process happens from the outside and goes in. It forms a skin layer on the outside and allows that bead of silicone to cure using the humidity from the room or the atmosphere that you have that in. Different parts of silicone, when we're talking about the atomic structure, if we're going to dive in deep, That is how we get high temperature. Elasticity. We can take it, stretch it, break it, bend it at different temperatures, use it as a thermal protection on wires, or we can use it as a semiconductor within a computer if it's silica or silicon based. So a lot of different things that you can do with silicone. Maybe it has an odor, maybe it doesn't have an odor. Maybe it's an acid cure, maybe it's not an acid cure, it's a neutral cure. So by identifying the use case, we can determine which type of silicone we need to use. Now, going to the RTV curing process. The room temperature vulcanizing actually takes adsorption into the process and not absorption. So adsorption is where the water molecules, the humidity from the room, the air, the shop that you're working in, etc., collects on the surface of that silicone. And that forms a skin layer and then works towards the center of that bead that you just laid down. So it doesn't absorb in, it adsorbs. So it actually goes through that silicone in a process. Now, when you're talking about the diffusion that happens in the center, that doesn't happen immediately. That takes time. And that's why you have cure windows. Some people like to, put a bead of silicone down, slap it together, and send it. It's good to go. Ideally, you're going to want to let that silicone sit and cure before you put it under any type of immense pressure or any type of stresses, shear stresses, tear stresses, heat, temperature stresses, right? It needs time so that it can cure. And the nice thing about a neutral cure silicone is that that water that it absorbs, it also desorbs that water, right? So it uses that water in the curing process, and it doesn't have any type of toxic fumes, acid smells like you would with an acetic cure. Sometimes you'll open up a tube of silicone, and let's say it's around the house. Maybe you're sealing up windows and you have a tube of silicone to keep the drafts out, and you'll smell maybe a vinegar smell, right? And what that is, that's the curing process that's happening with that silicone. It's releasing acetic acid, which is vinegar, and you get that strong odor. You don't get that with a neutral cure silicone, which is important in automotive and commercial trucking applications. We have sensors that we're dealing with. We have specific metallurgies that we're trying to seal together, whether it's aluminum, maybe it's brass, cast material. So we need a sealant that is capable of interacting with those surfaces and not causing any bad side effects, right? And here's a good example. When you're talking about some high temperature silicones, they can be an acetic cure silicone, and that acid can cause corrosion on the metal that you're trying to seal together. Maybe it's not metal, maybe it's plastic, maybe it's glass, whatever type of medium that you're trying to seal together. You're going to want to make sure that you're using the right application. The nice thing about Reinzosil is it's actually a neutral cure silicone. So it doesn't have those side effects of corrosion, ruining those O2 sensors like we mentioned at the beginning of the session. Those gases really can cause poisoning to those sensors, let alone to yourself, but hopefully no one's out here sniffing silicone. All right, 1-part silicone curing timeline. One thing to remember when you're talking about curing is that it is variable. You're not going to have a set linear timeline for curing, right? If you have a high humidity atmosphere versus a low humidity atmosphere, you're actually going to change the amount of time it takes for that product to cure in that application. So if I'm in a high humidity environment, my silicone sealant is going to cure at a much faster pace than if I'm in a low relative humidity environment. It's going to take much longer. So those are things to keep in mind whenever you're going to cure a part that you just sealed together, really to, and is it following the proper timeline in the environment that I'm working in? And here's a good example of a curing timeline between two pieces of metal. So let's just imagine that you just put your valve cover in place. Maybe you just put your diff cover in place, and The next day, you had to take it off for some reason. Maybe you forgot something. Maybe you forgot to put the ring gear in the differential. I don't know. But for some reason, you had to take the cover back off. You're going to see something like this. The outside formed a skin layer. You're going to see that curing process starting, but the inside is not cured yet. And so that's going, you're going to scrape it all off. You're going to have to clean that surface back down to the metal so that you can get good surface to surface adhesion and apply the silicone again. And so this is a really good example of seeing, number one, different thicknesses, right? So the thicker that you lay that bead down, the longer it's going to take for that cure to happen. And then ultimately, after a few days, it will be completely cured, and you're not going to have any issues. So there is a Q&A session I want to stop and just mention. At the top right-hand side of your screen, there's a button that says Q&A. If you have the opportunity or you have any questions that are coming up during this presentation, just type your questions in there. We're going to review those questions after the session is over, and then we're going to respond via email back to the group and everyone that received an invite so that we can give you the answers that you're looking for. So another factor when we're talking about curing silicone is weight loss, right? So the longer that silicone is in a high temperature environment, it will break down. So the higher the temperature is, for the longer duration, we'll start to see that material lose weight, degrade, and become brittle ultimately. Now, when we're talking about high temperature, we're talking somewhere around 250 degrees Celsius, 180 degrees Celsius, fairly high temperatures for extended periods of time. One of the nice things about silicone, okay, let's say you live in Minnesota, you live in North Dakota, you live in Canada, and now it's -20 outside. So your engine is sitting at an ambient temperature of -20 degrees Fahrenheit. Now, you're going to start the engine, you're going to let it warm up. 3, 4, 5 minutes from now, that engine is going to be somewhere around 180 to 210 degrees, right? So you're going to have a very wide range of temperatures that engine is going to go through, heating cycles, especially in the wintertime. And that's one nice thing about silicone, is that it holds up to the heat and then also does not degrade. We're talking about extremely high temperatures. And if your engine's getting to 500 degrees Fahrenheit, we got a problem a lot bigger than something that a tube of silicone is going to fix. Okay, so something to keep in mind there. Here's a really good example of silicone that has been overheated. It's been at 250 degrees C for 200 hours, and you're seeing this material, this high temperature silicone, break down. It loses its weight, it loses its rigidity and flexibility. That's another thing that has to maintain, and it really starts to crumble, degrade. And obviously you see an example there of Reinzosil and how it has held up, maintains its elasticity, maintains that ability to be flexible at a very high temperature for extended periods of time. Another test that we do is the Shore-A hardness test. And that's talking about that elasticity, making sure that it's still soft, it's still flexible after an extended period of time at elevated temperatures, right? Whether it's 500 degrees Fahrenheit, 600 degrees Fahrenheit, we want to make sure that that product is not going to fail, especially in a engine situation, right? If you have a sealant that's no longer a sealant anymore, and it allows that fluid to escape, then we have problems, right? So this is a durometer that you see on the left-hand side. This is going to push a needle down into that substrate, that sealing surface, and it's going to measure how hard or how brittle or how soft that product is. And you can do that with anything that's rubber. Really, you could do that with nitrile gloves, you could do that with rubber tires, you could do that with silicone bakeware, and you could see that flexibility and how hard or soft that product is. Here's an example of weight loss. So as you have a silicone in a set position, let's say it's in a mold, maybe it's in a channel, a valley inside of that head, or maybe it's inside of that valve cover, or maybe it's on the back of that diff cover, maybe it's on an oil pan. You want it to maintain its shape. You do not want it to lose weight. You don't want there to be any shrinkage. And one thing that we found is that when fillers are added into silicone to increase the volume, you will see a reduction in weight. You'll see a reduction in size because of fillers or extenders, if you want to call them that. And thankfully, Reinzosil, the way that it's been engineered, is that it maintains its form, it maintains its shape. If you're running a bead across those two surfaces, the last thing you want it to do is deform just because you had an extended period of time at high temperature. So another thing to take away from that example. When you're cleaning the surface of whatever you're trying to seal, want to try to make sure that you get as much grease, as much of the old sealant off, any oil, any residue, dirt, dust, anything that could be on that surface that's going to prevent adhesion. Yes, silicones flow well. They come out of the tube, especially a one-part RTV. You have two-part RTVs where you have two silicones that come together to have a chemical reaction for curing. A one-part RTV is very simple to use. It comes out of the tube exactly where you want it, has a very, normally, has a very pointed cone at the end, allow you to lay that bead very precisely. However, just because it flows well doesn't mean that it's adhering well. So you want to make sure that you're making that surface as clean as possible. And believe me, I think we've all seen a valve cover come off completely covered in oil, covered in dirt, covered from any type of dust. And if you don't get that cleaned off, you're not going to be happy with the results. So just keep that in mind whenever you're installing any type of silicone sealant. This is a really good example of imperfections. It's really zoomed in. You can't really tell the component that this came off of. But the nice thing about having a silicone that flows means that it's going to fill those dips and valleys and non-conformities in that surface of the component, whether it's metal, it's plastic, it's glass, whatever it might be, any type of impurities, not impurities, imperfections, that silicone will flow into there and create a nice seal on that product. So this makes it a little bit of a different situation than, let's say, a metal gasket, right? Where if there are any type of deep valleys like this, or any type of cracks, or not cracks, but micro abrasions in that surface, silicone is going to do a really good job here for you, and just making sure that it's clean and it's taken care of. So when you're talking about silicone sealants, there's some metrics that we like to look at from, okay, what is going to be appropriate for this situation? Why would I use a silicone for, let's say, a sensor safe application, right? We want to make sure that it's not going to put off any type of acids like we talked about earlier, but also weather resistance. So you think about UV damage. If this is a component that's out in the sun, it's exposed to any type of UV light all day long, every day, you want to make sure that you're using a sealant that's approved for UV exposure, to be outside and in the sun. Just like let's say that that kiddie pool that you left out in the backyard all summer long. Well, it's not as blue as it was when you bought it, and that's because of the UV light that's been tearing that apart, breaking it down. And that's a plastic, that's a rubber. When we're talking about a silicone, the same thing. We want to make sure that it's going to hold up to that UV light. And then also the temperature stability. Whenever you have in a literal working case, like northern Canada, or even parts of North Dakota, Alaska, you have very low temperatures in the wintertime. And we all know there's a lot of things that happen, right? Battery failures. You have coolant issues. Maybe the shop that you took your vehicle to last time, whenever they replaced the windshield washer fluid, did not replace it with a winter ready washer fluid. It's the dyed water, and now all of your lines are frozen, right, that are going to your wiper blades. That's an issue. And the same thing goes with any type of component that you're sealing. And we don't think about that. We don't think about the diff cover that we just put on. And is this sealant that I used around the edge going to be able to handle very low temperatures? So something to keep in mind in that range, how it's going to keep its elasticity at -40 all the way up to 200, 210, 220, maybe a little bit more depending on your application. And then chemical resistance. So when we're talking about water repelling, being physically touching gasoline, physically touching any type of a petroleum product, oil, oxidizers, that is going to cause wear and tear on anything, not just a silicone sealant. So you need to make sure that it does have strong chemical resistance. It's not going to have severe swelling whenever it's touching a fuel or an oil, right? If you're doing a valve cover, guess what? There's going to be oil that's constantly up against the surface of that silicone. You want to make sure it's not going to break down. The Shore A hardness, this is, we talked about that test on the last slide, and making sure that you're using a product that's not too hard and not too soft. It really does have to be a good balance. Reinzosil comes in right around 35 to 38, depending on the environment and the application. And then an electric isolator. So in today's age, when you're talking about electric vehicles, battery electric vehicles, hybrid vehicles, there's constantly concern from everyone, whether it's manufacturers to distributors to end users. There's constantly concern about, is this going to be safe? Is it compatible with high voltage, with low voltage? And the nice thing about Reinzosil and really silicones in general is they're a great dielectric. So it's not something that's going to conduct any type of voltage. It's not going to allow any type of current to flow through it. It's going to stop that, and it's not going to interfere with any other components. So something to keep in mind if you're working on a hybrid vehicle, to use that as well. And then here's some specifics, just talking about the basic properties of Reinzosil. We touched on this with the last slide. Now, shameless plug, the bottom right-hand corner, I used Reinzosil on the JL, and I got 10 more horsepower. I'm just kidding. I didn't, but it always sounds good, right? You put the sticker on there, it's at least 10 horsepower. And why don't you guys add at least 10 horsepower to all your vehicles? So with the properties of silicone, I want to make sure that you understand sealants are manufactured with a specific purpose. Whenever you are having a high temperature applications, manufacturers have a one mindset mentality. Okay, this is a high temperature silicone. This is the only purpose for this silicone. Or I have a sensor safe silicone. It's going to seal and it's going to be sensor safe. Or I'm going to create a sealant that's oil resistant. And so that's really been the mindset of silicone manufacturers from the beginning, is that it's purpose built. And shout out to all the chemical engineers that are out there. I'm not one of them. However, whenever you're looking at a specific purpose, they can nail down exactly what compounds are going to be perfect for that application. The one thing that kind of sets Reinzosil apart is through that cross-linking, through adding the different atoms and particles to that silica, to the silicon, they can create a product that is sensor safe. They can create a product that's high temperature, maintains its elasticity at low temperatures. They can create a product that doesn't cause a corrosion effect when it's curing on that application. Great flow rate, maintains flexibility, right? And that's what's so neat about Reinzosil, is that all of those things that we look at from a tube of RTV that's on the shelf at the store, man, okay, I'm doing a diff cover. I need one that, okay, where's the diff cover repair sealant. Oh, yep, here it is. The nice thing about the Reinzosil is that it was developed for all of those purposes, and you get all of that with one tube. I know it sounds a little cliche, but in this situation, one tube really does do it all. There's no reason to have a complete cabinet full of 20, 30 different tubes. This one's blue, this one's red, that one's black, this one's yellow because it's very special. So making sure that you're using, maybe cutting down on your garage space. I know I could get rid of a couple products just because they're redundant. Two products do the same thing. What do I have, all these different types of sealants for? So anyway, I hope that this was informative to you. I hope that you took away something new and that you learned something about silicone. We are the proud manufacturer of Reinzosil, and thanks so much for hanging out with us today. If you have any more questions, if you have anything that you want to find out, just put that in the Q&A section. We'll be happy to reach out to you here in a little bit. And I really appreciate your time. My name is Matt Linko with Dana, Spicer, and Victor Rines. We'll talk to you soon.